Hello everyone, I'm Thinking Tree, and today I opened my live stream. It's been a long time since I opened it. Today I was okay, so there is an explanation. Usually the reason why I'm doing a live stream is because if I want to rest, I know that uh, doing my homework or doing maths will actually benefit me instead of playing instruments or doing other things. So that's why I usually open the live stream. But these days I became quite sloppy. So I after doing all my works, I didn't put in extra works. So today I'll follow this first. So today I decided to open it, and for this one I did a uh, operation to get rid of the birthmark that I had. So please be understanding when I write words with my left hand. I am a terrible writer with my left hand. Oh, please believe me, this is not like what I write with my right hand. So 어젠다. um, yes, as I mentioned, please be understanding if my handwriting is weird. I'm planning to explain about the concepts that I recently learned because tomorrow is my biology test. So let's study together until I finish my homework. And if you like biology, please stay here to study about cells and their membrane together. I'll quickly go and watch my Oh, hello. I just saw it. I am currently in my home. Good evening. Today I came here to review for the biology test that I have tomorrow, and I will try to write as neatly as possible. But today, because the scheme might expand, I'm not allowed to use my right hand freely, so I will try to do my best. And the first thing that we learned in class is overall we learned about cell membrane, and we learned about the why is it over? Transportations in cell membrane, and there were two types of all the cell uncomfortable transportation. Please be understanding of the handwriting. I think the letters will be visible after the words dries. So there are two types of transportation in cell membrane, and the first one is passive transformation. I mean transportation. And the second one transportation, and the second one is active transportation. And the difference between passive transportation and active transportation is that passive transportation does not require any kind of energy, so it just naturally happens. And the second transportation is active transportation, and active transportation needs specific, I would say, compound named ATP, aka adenosine triphosphate, and it is done through the use of the energy release through ATP. Um, Before we talk about active transportation, there's one thing that I want to talk about passive transportation. There are, I think, three types of transportation, three examples of passive transportation that we learned in class. And the first one is diffusion. Uh, Mainly, this is the main one for passive transportation. In I actually wanted to say there is diffusion, osmosis, and facilitated diffusion, but all of them falls into the category of diffusion. So I will just say it as diffusion. And as I mentioned, the second was osmosis, and the third one was facilitated diffusion. Oh, my handwriting is so bad. So what diffusion is saying is that, oh no, a diffusion occurs when a substance enters the cell membrane freely, and the reason why this happens is because of two factors, which is polarity of substance and also the concentration gradient. So for the reason why this happens is due to concentration gradient, and concentration gradient is the difference in charges. No, I mean difference in the concentration of solutes in outside the cell membrane and also cytosol, which is inside the cell. So if there is a cell like this, if there are more substance here, then due to the kinetic energy that every atoms and molecules have, they will want to just keep moving to reach equilibrium. And for example, I think good example that every people say is if you're in crowded place, we would like to escape from crowded place to have more space and to reach equilibrium. And I think that's the best example that I ever heard and also could think of. And due to the concentration gradient and the kinetic energy of each molecules, they will try to either enter or either escape from the cell. And there are few substances that can enter or be released from the cell. And it must satisfy this. It must be small, first of all, because the membrane cell membrane is phospholipid bilayer, meaning there are two layers of phospholipid, and phospholipid is composed of two parts: hydrophilic head and hydrophobic tail. So I think this diagram is what this diagram is quite famous, but it basically looks like this. No, my drawing is bad, obviously. So this is hydrophilic. Hydro, water, philic, loving. Water, loving. Or we can say that this head part is polar, because water is polar. And this part is hydrophobic. The tails are hydrophobic, meaning they hate waters. They favor more nonpolar molecules. So if the molecules were small enough to enter this bilayer, and if they are non-polar, I'll just write it here. Non-polar. If they are non-polar, they might have hard time going through the head, but they will be more favored in the tails. So if they're small and non-polar, they will easily pass through the phospholipid bilayer. Yes. And that is basically the reason why diffusion occurs. And osmosis is a special type of diffusion. So osmosis is when water diffuses into the cell membrane. Oh, by the way, fluids, including gas and liquids, they can diffuse readily because, first of all, they're quite small. Most of them are nonpolar, so they can easily enter the cell. So osmosis occurs when there's two types too for this one. I forgot the terminology. I think I got it. Hypertonic and hypotonic. There are two cases for osmosis, and it is hypotonic and hypertonic cases. This is teachers usually say that if there is a cell like this and container, if there is more solutes here, we say this is hypertonic. And my handwriting. This is if there's little solution here, it's hypotonic. But actually, there is a correct way of saying it. The correct way of saying it is the region outside the cell membrane is hypertonic to the cytosol. Or we can say that the cytosol is hypotonic to the region outside the cell membrane. And now, because of concentration gradient, like I mentioned, because molecules are constantly moving, and also they want to reach equilibrium. They will want to, the molecules will want to either go into the cell membrane or escape from the cell membrane. And in this case, if this was starting point, then obviously the water or fluids will like to escape from the cell membrane. And the reason why it wants to escape is because if the outside is too much solution, so for example, let's say there's a container like this, if the let's say the solute in this case is salt and the solvent is water. There was also terminology. Aquaporin is aquaporin, and in this case, because they want to have equal solution, the water in here will want to escape. Then the ratio between the number of sodium chloride or the salts particles and the water will be equal. That's why in this case, the water will like to escape. Now there is other case. Oh, what? There's other case where the outside has less solvent compared to the inside. In this case, the outside water would like to go in to the cell to reach equilibrium. I think that was it about the. I think that is it. If I did not miss anything. There's more iron structure. Yes, and also the reason why this is important is because of homeostasis. Cell wants to keep. Cell would like to keep few substances while they will like to release the others. Mm, aquaporins are types of proteins, I guess. I should research more about that. And hyper. Yes, I think this I mostly explain about everything except when they reach equilibrium. I said in this case the outside is hypotonic in relation to the cytosol, while in this case the outside region is hypertonic to the region inside the cell. Then what if due to the kinetic energy they are equal? Due to the concentration, due to osmosis, if they become equal, we call this state isotonic. So there are three: hypotonic, isotonic, and hypertonic. Yes. Um, and I also forgot to explain one other one for osmosis, and it is for uh, unicellular organism. Unicellular organism has contractile vacuole that allows this osmosis to happen. So let's say there is a big paramecium. I think paramecium has, yes, I think most of them do. And why am I keep saying vector? Contractile vacuole is doing what they're doing is that uh, if they need more water, they first open their cell membrane, not open, but they gain more cell membrane through osmosis, and they trap them using their vacuole. And this time it is contractile vacuole because the vacuoles can actually collect the waters, hold it, and if they don't need it anymore, they can also release it. And trying to observe and release water, it requires energy for contractile vacuole. Yes, I think that was all for osmosis. And in terms of plant cells, there's also one more thing about osmosis. I was just right what I need to study one more time. Green contractile. About plant cells. Plant cells actually prepare their cells to be expanded quite a bit because for animal cells, they will pop. which is also known as, I guess, cytoplasm. No, not cyto, plasmolysis and cytolysis. Yes, cytolysis. Cytolysis means lysis mean dead. So cytolysis. So pops open and it dies. And I think plasmolysis when okay. So there are also three cases. There are for plant cells. I'll just say two because there is. Did I say? Oh, okay. So there is a cell that is doing well, and if it gained more water or gain more solute, gain more solute, it became like this. It expanded. Then in plant cell, it is called target. They're target cells. And the pressure that is pushing the cell membrane and also cell wall in plant cells is also called Target pressure. Now, plant cells usually don't pop or cytolyze. Cytolyze, I don't think that's the right term, but they don't experience cytolysis because they have very rigid cell wall. But for animal cells, if they became too big and big, they will, because they don't have cell walls, they will eventually experience cytolysis, then our poor cell dies. It's so sad. That's why there's another case in which they the cells lose solute and they became like this. And this case is known as flaccid for plant cells, and usually we say plasmolysis. Yeah, plasmolysis. And have you ever experienced a plant dying because you did not water them? So if you don't water your cells, if you don't water your plant for a long period of time, they will wilt and they will lose color. They will eventually die. And the reason is because they do not have enough water here. The cells become flaccid and also known as plasmolysis. Cells. That's why plant cells actually favor more water and have target growth pressure and become target. I think that's all about osmosis. I think so. And the last part from section 1 out of section 2 that I want to talk about is facilitated diffusion. Facilitated diffusion is diffusion that occurs because the normal diffusion does not occur because I'm using too much because for the ions, because again, since the substance that try to go into the cell is charged, so they are ions, or they are too big, or they are polar. In that case, they use something called protein channel. Protein channels are they are integrals, not the math integral chocolate, but very beautiful thing. Anyways, if there is a cell like this, there will be integral proteins or proteins that are embedded in cell membrane. So if substances that are too big or polar wants to go in, they cannot go through normal phospholipid bilayer. And they receive help from channel protein. The channel protein there will be gated proteins, I think, and I think that's for active. So I think in this case, channel proteins, I hope they are always open. Channel proteins, when they receive objects, they will slowly change their shape like this and observe the substance that they want to gain. So this is also part of, and this is an example of passive transportation, so no energy required. And this is just saying that there is a protein, there are multiple proteins that assist in gaining substance that the cell wants. And there's also a thing called ion channels because for some reason, I'm not sure why, but ions are hard to get into the cell, so they need a specific proteins that assist in diffusing ions or charged particles. So this was it for my section 1. So, and there's only section 2 left. Section 2 is way shorter than section 1. Section 2 is about active transportation. And there's one pump that we learned. It is called sodium potassium pump. And sodium potassium pump is actually really important in our body. First of all, as I mentioned, active transport requires energy. And there is a specific form of substance that the pumps require. They are ATP, adenosine triphosphate, and ATPs they release energy by breaking the bond here, right here. When they break the bond, they're very unstable. So when they break the bond, the energy is released. And they use the energy to change the shape of protein that I will explain soon to allow the transportation to happen. And one thing, very good thing, is that those phosphate groups, they don't disappear. You can keep reusing. Only the bonds are broken. And when they become ADP, because the bond is broken, they also break the bond one more time to reuse the energy. I think it is very funny when people say all of these happen because of coincidence. I'm not trying to be disrespectful, but it's just my personal opinion. So sodium potassium pump, they have few procedure. And just to be sure, I will just open my textbook. So in a carrier protein, the protein that assists in transportation, there are these two rooms. I'll just draw one. So the transportation only happens when sodium ions, 3 sodium ions, which is Na plus, is inscribed here. When the sodium ions are placed here, all 3 of them, then ATP will travel and then make their place here. Now, soon their bond will be broken, and due to the energy, the carrier protein will change its shape. And the sodium ions, the 3 sodium ions, will all just fly away. And the external 2 potassium ions will enter here. If those 2 are inscribed, then the protein will change the shape again. and allow two more potassium ions to come into the cell. And actually, this does multiple things for our cell. First thing that they do is they make our cells slightly negative, and being our cells being slightly negative is actually good because they help in signaling of the cell. We didn't learn specifically about how the signaling works, but I think that's how it is. And also, this information was not included in our textbook, but just to inform, they have different number of sodium and potassium ions going in and out. So without so this process is actually really fast and it occurs multiple times in our cells. And if this process does not occur, our cell volume will constantly increase because there are more sodium ions. Then they will eventually pop. So to prevent that, the cells release 3 and gain 2. So they regulate the cell volume too. Very smart, I personally think. Our textbook somehow made this into 5 steps. One, two, three, four. But they're basically the same thing. So I will just keep it like this because I think understanding is much more important. And this process is also important because there is a secondary transportation that occurs. Yes, and also the official name of the difference in charges that I mentioned is electrical gradient. There is the secondary. Uh, I should. There are a few things I need to review. The secondary transportation that I want to explain is uh, in the cell. I said two potassium ions will come in due to the reaction that you see right here. And this is called antiport. Uh, so when 3 sodium ions are released, they will actually, yeah, I remember. So these 3 sodium ions, they're able to go in and out the cell passive ways. So through using ion channel, they can easily come in and out too. However, in this specific case, they're not passive because if they want to bring glucose together, glucose is a carbohydrate that is very big molecule, C3, C3, C3H12O6, I think. Yeah, C3H12O6. And if they want to bring glucose, this is called symport. This process is symport, and I think this process is also known as sodium glucose transporter. Sodium, this is another type of protein, I guess. Sodium, no, not I guess. It is another type of protein. Sodium glucose transporter, called transporter. Transport. Please be understanding of my handwriting. Thank you. And also, glucose, they are polar. So it's actually really bad. I mean, not bad, really hard to get into the cell because, first of all, it's big and it's polar. Because I mentioned in the previous part that the substance must be small and non-polar to enter readily into the cell. That's it. So when sodium, released sodium wants to come in with glucose, it is usually not active. It's usually passive, but it becomes passive when they bring glucose together. When they couple with glucose, then they will use another sodium glucose co-transporter, also known as Symport. What's it, Symport? Yes, Symport, to actively let glucose into the cell. Because glucose is very important, sugar is very important, so it's in our body. Now the last really final thing that I want to say is endocytosis and exocytosis. Endocytosis and exocytosis, they're really, really simple. There's not much to talk about that. And yes, it is endo and exo. So what do you think will be endocytosis? Endocytosis is because we say cytoplasm, things inside, like jelly-like fluid inside the cell. Endo, in, or need, bring. Cytosis, something related to inner cells, bring substances into the cell. So there is endocytosis and there is exocytosis. They're both done through vesicles or small organelles that transport substance. And endocytosis, they requires energy. They requires energy, and they transport many and small molecules at the same time. Um, and also this also helps when the substances. I really need to review these words. When the substance is too big, they also use endocytosis and exocytosis. There are two types for endocytosis. Is pinocytosis and phagocytosis. Mm, and fused. So this is drinking, eating. Oh wow, I cannot understand what they meant. So pinocytosis is when the endocytosis is used to get fluids. However, phagocytosis is when the endocytosis is used to gain substances. Yeah, I think that's everything to note. So from my memory, from now on, exocytosis is just the opposite. It releases materials, and it's very intuitive how it occurs. There is a membrane, substance that we want. Membrane changes its shape. Membrane will I would say membrane will fees. I don't know if fees is a correct word, but it will separate themselves from the normal membrane and eventually create a small vesicle that is carried around. Very simple. Now then, how do exocytosis occur? Exocytosis, they begin from Golgi apparatus, which is like a packaging center in your cell, and they will allow the substances or even substances to or their vesicles to fuse together with the membrane. So it's just the totally opposite. In this case, they will be separated. For exocytosis, they will fuse together. And there's also phagocytosis, lysosomes, the vesicles that detoxify themselves. Peroxisome also does it, but lysosomes like lysis, so the one that helps in cellular cell lysis, it also fuses with the cell membrane because they're phospholipid bilayer. I think this was it for the review. Just to quickly go over what I need to study. Um, Aquaporin is one type of proteins. I think that assists in getting water. Don't quote me on this. Contractile vacuole is the vacuole that only exists in unicellular organism that is active and also allows help in help the cells to be hypotonic compared to the outside or hypertonic compared to the outside. And protein channels, they are embedded in the cell membrane. Some of them for facilitate the diffusion, they are passive. And secondary, I will just quickly re-explain it. So when there are two proteins like this is primary and secondary. So two potassium came in, three sodium ions released. And the three sodium there used to be passive, but when they couple with glucose, they will come in together using sodium glucose co-transporter to actively enter the cell. And the reason why glucose needs help is polar and very big. Thank you so much for being here. I really appreciate two people who hopefully enjoyed biology with me. Thank you so much. And I will try to start studying again and frequently open my live stream. And thank you. Then hopefully see you tomorrow. Thank you.